Assalamualaikum and hi, my name is Nurul Aizlaga with Mizat. My matrix number is CN230121. Our group is discussed about center and center of gravity of the boat. A boat is a watercraft designed for navigation, whether it's on water or through the water. The size is typically smaller than the size of the ship, and it comes in various forms and designs for its specific purposes. And there are many types of boats such as canoes, fishing boats, dinghy, sailboats, rowboats, and many more. So boats have different design for various purposes because of the specific requirement for each activity. For example, fishing activities, race activity, and many more. So boats that design for speed, such as speedboat, racing boats, their design are prioritized to the shape of the boat and the lightweight materials to maximize the speed and also stability. For example, like fishing boats, their design are focused to balance and the steadiness to ensure that the platform are stable for the fishing activities. Other than that is cargo capacity. For example, like container ship, they need a large space to carry a large amount of goods. So their designs are prioritized to cargo capacity and stability, and not only that, but also fuel efficiency. Our objective of this project is first to identify the centroid of each part of the boat. Second is to find the center of gravity of the boat. And the third one is to determine the principles and concept for the boat stabilization in daily life.
So now I would like to present the centroid and center of gravity theories. First and foremost, let us know what is the centroid and center of gravity. Centroid and center of gravity is the point which locate at the gravity or wakes of the body and also known as center of mass. There are three types of centroid, which is centroid of lines, centroid of areas, and centroid of volumes. The centroid of line which only involved in one-dimensions objects such as ropes and wires, and this type of centroid measure in length. For centroid of areas and two-dimensions object which measure in length and width, and area are considered. Next, centroid of volume are three-dimension object y with coordinates x, y, and z to measure the volume. So what can be affect the boat stability when there is a wave? Stability of vessels can be determined by metacentric height GMs, which can track the stability of ships for a range of hills angles. When there is a wave from sides, it can cause the metacentric height of the ship become negative, and the ship is now not in stable conditions and can sit facing the heeling moments. Next, for the vessel with full loads will also cause vessel less stable because adding weights above boat's center of gravity will cause boat stability to be decreased and the raise of the center of gravity. As there is raising of center of gravity, less heels is required to capsize the vessels. Vessel with large depths may tend to ship waters and can cause them less stable. So now I would like to pass to my friends to continue.
Hi, my name is Ainul Fatia Binti Azmi. My matrix number CN230124. I will explain how to calculate to get the centroid. After I divide the parts and get the shape of each part, I can start counting. For the first and third part, we can see it is a triangular. The formula calculating area is length times height, but for the triangular, it is 1/2 times length and height. After finishing calculating the area, we need to add it to get the total area. So the total area obtained is 47460. Next, To calculate the x-axis, we can see on the diagram that the head is 70 cm and the length is 780 cm. We can also see the y-axis is in the middle. So, we need to divide by 2, which is 17 divided by 2, and we will get 35 cm. To find the length of the y-axis, we need to subtract 780 cm minus 18 cm to get the length from area 4 to 6, and the total length obtained is 635 cm. However, for the y-axis of part 1 and 2, 80 cm divided by 2 will get 40 cm. Indirectly, we can get the value of the y-axis for part 3. In part 1 and 3, the formula to get the value on the x and y-axis is the value of the axis divided by 3. For the other part, it is necessary to divide by 2 to find the centroid of an area. Then, we need to calculate the total x and y axis. X and y axis need to be multiplied by the area to get the value. After obtaining the value, we need to total it. For the x axis, I got minus 46620, and for the y axis, it was 283528. After finishing the calculation, we need to get the centroid. We need to divide the total value x or y by the total area. For the x-axis value is minus 0.98 and the y-axis is 5.97.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amiruddin bin Muhammad Arman. My matric number is CN 230194. Now I want to talk about conclusion. So the best practice solution based on the static principle and concept for both stabilization is number 1, proper weight distribution. The load are distributed evenly to prevent imbalance. Second, low center of gravity. Keeping the center of gravity low ensures better stability and reduce the risk of tipping or overturning. Third, metacentric height. The larger metacentric height generally result in greater stability, while a very small metacentric height may lead to instability. Fourth, regular inspection is to help identify potential problem or issue early before they escalate. And lastly is material selection, is choosing appropriate material based on their strength, stability, elasticity, and other mechanical properties is vital. Okay, that's all from me. Thank you.